Hi, ladies and gentlemen, Mr. Green. This is the last lesson in our statistics unit, so I want to make certain I get to it. So far, I've been talking a lot about the normal distribution, and I want to make certain that I express to you some of the points about a normal distribution so that you understand what we're looking at. A normal distribution is mounted in the middle here. This right here, you see how it's got this Greek letter right there? It's called mu. That is your center. So in lesson one, we looked at centers. This would be the mean. That's what this mu means, is the mean. And this point right here, well, this is your uh, what we did in the second unit, where we were looking at the uh, uh, how far it's moved off center. This is your standard deviation. So this is -1 standard deviation. This is +1 standard deviation, and then +2 standard deviations, and -2 standard deviations, and +3 standard deviations, and -3 standard deviations. Typically, most of the area underneath the normal curve is taken up in 3 standard deviations. That's what a standard normal distribution is all about. Okay? So if we were looking at this graph as representative of this particular question, it says the amount of time in minutes that consumers spend in a convenience store are normally distributed with a mean of 14 minutes and a standard deviation of 3. So what we would be looking at down here is this is time here, and this is 14 minutes right here, and standard deviation of 3, this would be 11, and this would be 17, and this would be 8, and this would be 20, and this would be 23, and this would be 5. And that's the way you can get that horizontal axis numbers in there, just like that. Okay? It says about what percent of the times are between 11 and 20 minutes. So let's look here. Just where is 11 minutes? Right here. And where's 20? Right here. So between 11 and 20 minutes, we're looking at this area under here, right? Well, how do we find that information? Well, I want you to notice that um, what we're looking at is this one standard deviation here. This represents about 34%. And this one here is about 34%. And then this one over here is only going to be about 13.5%. So if you add those three values up, what you get is about 81.5% of the entire area. Now there's a rule that goes along with this, okay? It's called the 68%. Let's see, I can't remember the exact name of it, but 68% of it is within one standard deviation, and then you can add 2 times 13 and a half and add that onto it, and that's the second standard deviation. But that's how you figure this out, and you'll talk about that more in the lesson itself, so I think you'll need to go read the lesson. It said about what percent of the times are less than 23 minutes. Well, here's 23 minutes, and look at this. Almost everything there, isn't it, is less than 23 minutes. And a matter of fact, what we're going to be looking at there is that 97.5% of the time will be less than. Ah, used the wrong number there. So let me just erase that. That's the wrong number. There you go. Okay. So this is about 2.5% out here at this end out here. And so I'm going to take 100 minus 2.5, and I'm going to get a 5, 7. And it's still 97.5%. Hmm. So they're saying 99.85%. I'm not going to belittle their point here any. What they're doing is they're taking, this is 50% here in here, and then this is 34% and this 13.5%, and then this is 2.35%, leaving just a little bitty bit out there. Okay? Okay. So, one of the things that you're going to be looking at in statistics is a thing called a z-score. So, here's what they did. Instead of labeling these things with values underneath here that represent a specific graph, they normalize this a little bit. And what I mean by normalizing it is they're going to divide these numbers by the mean, okay? And they're going to find the difference here for 1 standard deviation and 2 standard deviations and 3 standard deviations, okay? And so what we're looking at is actually the x minus the mean divided by the standard deviation, and that's what we're going to get, and that's called a standard normal distribution. These z-scores are actually in tables that you can go look them up, okay? And so if we want to find the z-score here for 415, well, 415 is right here, right? So in a standard normal, it's going to be somewhere like right in there, right? So what I'm going to do is I'm going to take 415, I'm going to subtract 400, like that, and I'm going to divide by the standard deviation of 10. How did I know the standard deviation was 10? Well, the difference between here and here is 10, right? And so what do I get? I get 0.15 divided by 10. I get 15 divided by 10, and that's 1.5. Okay? Let's try another one. 372 minus 400 divided by 10, and that's going to be 28 divided by 10, or 2.8, and it would be a negative value. Okay, so 398, that's going to be 398 minus 400 divided by 10, that's negative 2 divided by 10, and so you're going to get a 0.2, a negative 0.2. And our z value should reflect that. Okay? Cool. So you now know how to find a z-score. That's one of the harder topics that you will run into when you're looking at statistics, is being able to find that z-score and then to use that z-score information. Okay? So, having discussed this with you a little bit, I want to make certain you understand it. This is the topic that you're going to be looking at in this unit. We're finished with Unit 5. We will be moving on to Unit 6 next time.